Hey guys, welcome back to my channel. So today we're going to do paper 1 for IGCSE Cambridge, paper code 0580. And today we're going to do the first variant of paper 1. This is from the May June 2025 series. So by now you have like a second sample for how the non-calculator paper is going to come. Because you know that they've changed the pattern now. Paper 1 and paper 2 are non-calculator. So with this paper and like with all of the three variants, you have a good number of examples to know like the type of questions that they're going to give, how you're supposed to solve it. And with the help of this video, you'll also know several tips and tricks which you can use to remember basic concepts and to save time while solving paper 1. So let's start with the first question. It says write the number 10069 in words. So very simple, you just need to write this number in words, which is 10,069. So you just write 10,069. Simple as that. Then write 10,069 correct to the nearest 10. So this is rounding. So if they're asking you to round to the nearest 10, what we do is we look at the units number, the ones number, which is 9. Now 9 is 5 and above, which means the tens will be rounded up. If 9 was less than 5, then the tens would be rounded down. So since it's 9, that means 69 becomes 70. So it's going to be 10,070. Remember, if it's 5 and above, you round up. If it's below 5, you round down. Then convert 10,069 centimeters into meters. So 1 meter is 100 centimeters. 1 centimeter is going to be 1 over 100 meters. When you go from a bigger to a smaller unit, you times. When you go from a smaller to a bigger unit, you divide. Centimeter is smaller than meters, which means we will divide 10,069 by 100. So 10,069 divided by 100 is going to be 100.69. The reason why it's 100.69 is that every whole number has a decimal at its end. If I write 5, 5 is the same as 5.0. So remember that 10,069 is the same as 10,069.0. So if we add the 0.0 over here, next thing you need to remember is that when you're dividing by 10, 100, 1,000, 10,000, 100,000, million, anything, we move the decimal towards the left side. And the number of places the decimal will move to the left side depends on how many zeros there are in the denominator. 100 has 2 zeros, which means you'll move the decimal 1, 2 places to the left. When you move it 2 places to the left, it comes between 0 and 6. Hence, the answer becomes 100.69. So you need to be aware of these very basic tricks in order to save time. And as you know, this is non-calculator, so you can't use the calculator to solve this question. So if you don't know this, you won't be able to get the right answer. So you need to know your basic metric conversions, how much is kilometers into meters and vice versa. Then for centimeters to millimeters, meters, liters, milliliters, kilograms, grams, the basic ones, you need to know these. Then it says a bag of sweets costs $0.34. Arun buys 10 bags of sweets. Work out how much change he receives for $5. So one bag costs 0.34. So for 10 bags, we do 10 times 0.34. Now in the previous question, we were dividing a number by 100. Now we're multiplying a number by 10. So if we're multiplying by 10, 100, 1,000 or so on, we move the decimal to the right-hand side. And the number of places it moves to the right-hand side depends on the number of zeros we have. So a 10 has 1 0, which means this decimal moves 1 place to the right, which makes it 3.4. So $3.4 is the cost of 10 bags. if he's paying $5, how much change is he getting? So we do 5 minus 3.4. Now, when you're subtracting decimals or like a decimal from a whole number, the thing I said before, every whole number has a decimal at its end. So we add a decimal after 5 and make it 5.0. The reason why I'm doing this is because when we're adding and subtracting decimals, the decimal comes underneath the decimal. We can't write 5 and then, 3.4 like this. That's wrong. This is your ones. And the number before the decimal is ones. 3 ones, 5 ones. And the number after the decimal is tenths. So your place value has to be aligned. Ones come underneath the ones, tens come underneath the tens, and so on when we're dealing with decimals. So to make it simpler, just add a decimal after the whole number and make it a decimal number. So 5 becomes 5.0, and now we're subtracting 3.4 from 5.0. Since 0 is less than 4, we can't subtract them. So we need to make it bigger than 0. For that, we carry a 1 from 5. So 0 becomes a 10. 10 minus 4 is 6. Put the decimal down as it is. 5 is a 4 now. 4 minus 3 is 1. So $1.6 is your answer. You must have realized this was a very basic calculation. Like this is something you have learned in year 5, year 6. So in non-calculator papers, you need to remember those basics that you learned years ago as a kid. And now you have to apply them again in these exams. So revise your basics. Make sure that you know your times table. You know how decimals work, the metric conversions, as I mentioned earlier. Like very simple things. You're going to be tested on very simple things in majority of the questions. Then two numbers have a sum of -2 and a product of -15. Work out the two numbers. So let's assume that the numbers are x and y. So x plus y is -2, and then x times y is -15. So now we know the factors of 15 are 5 and 3, 15 and 1. If we do -5 times 3, that's -15. And if we do -5 plus 3, that's also -2. So our numbers can be -5 and 3. You just have to list down your factors of 15 first to make it easier for you to solve, because having a sum and getting an answer of -2 can have several combinations. So it's best we look at the product, because 15 has a limited number of factors. So we list down the factors, pick the combinations, and see which one works best to get the sum of -2. Then we have a list of numbers and they want us to write down what each is. So we have to figure out what's an even number in this list. So even number is a number that ends with 2, 4, 6, 8, and 0. So in this case, it's 112. A square number is a number that we get when two same numbers are multiplied. For example, if we do 3 times 3, that's 9. So 9 is a square number. So over here, if you notice, 49 is a square number because 7 times 7 is 49. So you need to know your basic square numbers, like at least like till 12 or 13, you need to know your square numbers for this paper. You need to know your cube numbers as well, like the basic ones. Like at least till like 5 or 6, you need to know your cube numbers as well. Then it says a factor of 56. We know 56 is divisible by 7, 8, 2, then 28, 56, 1. Over here, 7 is given, so we can just choose 7. Prime number. This is something that most kids still confuse to this date. Prime number is a number that is only divisible by itself and 1. Your smallest prime number is 2. It's not 1, it's 2. So it's 2, 3, 5, 7, 11, 13, and so on. So prime number will be that number that only comes in its own times table and the one times table. That's it. So over here, if you look at our numbers, 7 is a prime number because it only comes in its own times table and 1. 27 is not a prime number because it comes in the 3 times table, 9 times table, and the 27 times table. Same with 39, 49, 99, and 112. Every other number is not a prime number. So 7 is the only prime number that we have. Then it says write down the reciprocal of 5. Now, reciprocal is the term that you must have come across when you were learning fractions. Now, when we say reciprocal, what we mean is that we're flipping the fraction. If you remember, when you divide fractions, you always take the reciprocal of the second fraction and change the multiplication to division. So when they ask you to take the reciprocal of like a given number, what they're asking you to do is that you have to flip the fraction. Over here, 5 is a whole number. But if you remember, 5 is also the same as 5 over 1. So now it's a fraction. So in order to flip this fraction, we swap the numerator with the denominator, which means the reciprocal is going to be 1 over 5. So for reciprocal, just flip the term. If it's a whole number, remember that every whole number has a denominator of 1, which means when you flip it, it becomes 1 over the given number. Very small basic tricks that you need to remember at all times to score high marks in this exam. Then question 6 says put one pair of brackets into each calculation to make it correct. So what we can do is, for this, obviously, you'll use trial and error first to figure out what works. If we add brackets over here, for this, you need to remember rules of BODMAS, PEMDAS, whatever you call it. BODMAS says that we solve brackets first, then we solve indices, then we divide, multiply, add, and then subtract. This is the order that we follow. You start with brackets and end with subtraction based on what is given in the question. So since we have to add the brackets, if I add brackets around 5 times 4, we solve 5 times 4 first. So that's going to be 7 minus 20 plus 8. Now 20 plus 8 is 28. So 7 minus 28 is not going to be 16. It's going to be negative 21, which means we have solved the second one. So this is where the brackets come for this one. Now let's figure out the first one. What if we add the brackets around 7 minus 5? 7 minus 5 is 2. Then we have 2 times 4 plus 8. 2 times 4 is 8. 8 plus 8 is 16, which is exactly what the question is asking us to show. So this is where your brackets will come. So for this, use trial and error. Remove your brackets, place them somewhere else, and see which gives you the given answer. Then it says a ticket costs $18. Write down an expression in dollars for the cost of T tickets. So if one ticket costs $18, T tickets will cost 18 times T. Then a bag contains n red balls and 16 green balls. Write down an expression for the total number of balls in the bag. So if there are n red balls and 16 green balls, total balls are 9 plus. Total balls are n plus 16. Then write 90% as a fraction in its simplest form. So 90% means that the fraction is 90 over 100. Every percent has a denominator of 100. So if we rewrite the percent as a fraction, just add a denominator of 100 to the number. So now when we're simplifying fraction, first thing you need to remember is that we can always cancel out the 0. If there's one 0 at the end and another 0 at the end of the denominator as well, you can cancel them out. So that leaves us with 9 over 10. And since 9 and 10 don't come in the same times table, so this is our simplest form. Next, write 3 over 100 as a decimal. So same thing as I told you initially. Assume that this is a decimal after the whole number. So if you're dividing by 100, that means we move the decimal 2 places to the left, which means it's going to be 0.03. Then it says these are the first 4 terms of a sequence, 33, 26, 19, 12. Write down the term-to-term rule for this sequence. So to figure out the term-to-term rule for this sequence, what we do is we see whether there's a common difference between each term or not. If we subtract 26 and 33, we get a 7. Then for 26 and 19, it's again a 7. And for 19 and 12, it's again a 7. Which means each term is being reduced by 7. So the term-to-term rule for the sequence is going to be subtract 7. Then work out the next 2 terms in the sequence. So we do 12 minus 7, which is 5. And then we do 5 minus 7, which is negative 2. So the terms are 5 and negative 2. Then it says these are the first 4 terms of another sequence, 19, 23, 27, 31. Find the nth term. So for the nth term, the initial step is still the same. We find the common difference. So 23 minus 19 is going to be 4. 27 minus 23 is also 4. And 31 minus 27 is 4 as well. This shows that you have a common difference of 4. So whatever the common difference is, if it's being added, that means we write 4 times n. If it was being subtracted, you would write negative 4n. Once again, if the sequence is increasing in size, that means each consecutive term is being added by a common number. So that common number is multiplied to n for the nth term. And if the sequence is decreasing in size, then that common number is being multiplied to n, but we write a negative sign with it as well. Right now, our nth term is 4n. Let's see if we can get the same sequence with 4n. T1 is going to give us 4 times 1, which is 4. Now, this is obviously not the same as the first term. How can we turn 4 into 19? We can add 15 to this. Now, let's say our nth term is 4n plus 15. So, let's use this to find the second term, which should be 4 times 2 plus 15, which is 8 plus 15, and that gives us 23, which is exactly the same as the number in the sequence, which means the nth term is 4n plus 15. You can always check your nth term by substituting 1, 2, 3, or 4 and see whether you get the same term as given in the sequence. If you don't, that means you need to make your nth term again. Then it says Kai cycles from his office to a meeting and back again. The travel graph shows his time at the meeting and his journey back. How far is the meeting from his office? It's 14 kilometers. Because if you look at the graph, he's starting over here and then he stops over here because now there's resting period. Why is this resting period? Because no distance is being covered. So how far is the meeting from his office? It's 14 kilometers because that's when the graph stops and is constant. Then it says, how long is Sky at the meeting for? Based on the graph, he reaches for the meeting at 11. And till this time, the meeting is going on. So that means we have 1, 2, 3, 4, 5, 6 boxes between 9 and 10. So that's 60 minutes from 9 to 10. So there's 6 boxes. That means each small box would be 10 minutes. The meeting is for 40 minutes. Then it says, write down the time Kai arrives back at his office after the meeting. This is where the meeting is going to end. So we know that each small box represents 10 minutes. So this is going to be 11:10, 11:20, 30, 40, and 50. He is going to reach back to the office at 11:50. Then it says Sky cycles from his office to the meeting at a constant speed of 21 kilometers per hour. Complete the travel graph. So his speed is 21 kilometers per hour. Distance is still the same for going from the office to the meeting. That's 14 kilometers. So 21, which is the speed, equals to distance, which is 14 divided by time. So we do 14 divided by 21. So 14 divided by 21 is 0.6 recurring. So if I times it by 60, that's 40. So 40 minutes is the time it took him. So it will take him 40 minutes to go from the office to the meeting place. So this is the point at which it shows that he's at the meeting. So from here, we go 40 minutes down. So this is 10, 20. So 10, 20, 30, 40. This is where he begins to leave for the meeting. So this is our starting point, 9:40, 0. And this is our endpoint where he's reached for the meeting. So this is how you complete the graph. You need to be aware of the different traits of a distance time graph and even a speed time graph. Because in a speed time graph, your slope gives acceleration, area under the graph gives distance. For a distance time graph, your slope gives speed. Area under the graph doesn't really represent anything over here. So basic properties of a distance time graph and speed time graph are very important for these types of questions. The next question says, calculate the volume of a cube with side length 3 centimeters. So a cube has the formula of length times width times height for the volume. So a cube has the same length for all sides because all faces are squares. It's going to be 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. So 27 centimeter cube is your answer. Then solve 5x plus 8 equals to 3x minus 2. So this is an example of solving a multi-step linear equation. So what you can do is you can collect the like terms on each side. So over here, 5x and 3x are like terms. 8 and negative 2 are like terms. So you can bring the variables on one side and the constants on the other side. So 5x minus 3x equals to negative 2 minus 8. So when we move a term from one side to the other side, what happens is the sign of the term changes. If it's positive, it becomes negative. If it's being multiplied, it divides on the other side. So since it was plus 8, on the other side, it's minus 8. Since it was plus 3x over here, on the other side, it's minus 3x. So 5x minus 3x is 2x, and this is negative 10. X is negative 10 over 2, which is negative 5. That's your answer. Then work out negative 5 times negative 4. Whenever we're multiplying two negative integers, the answer is always going to be positive. So 5 times 4 is 20, and since they're both negative, the answer would also be positive. Now, when you're adding a negative integer to a negative integer, what we do is we add them. It's basically going to be 8 plus 3, which is 11, but the sign will be negative now. Then 3 to the power of p times 3 to the power of 4 equals to 3 to the power of 10. Find the value of p. This is the rules of indices. Whenever you have similar bases being multiplied, what we do is we add the powers. So on the left-hand side, it's going to be 3 to the power of p plus 4. The base is the same, which is 3, but what we do is we add the powers. And this remains as it is because it's on the other side of the equal to sign. Now, whenever you have the same bases on each side of the equal to sign, we can put the powers equal to each other. So p plus 4 equals to 10, and then p is going to be 10 minus 4, which is 6. So first thing, whenever similar bases are being multiplied, you add the powers. If similar bases are being divided, you subtract the powers. The base does not change. What changes is the power. Then once you have combined the powers, if there's a similar base on both sides of the equal to sign, we can put the powers equal to each other. And with that, you can find the value of p. Then it says complete a net of this cuboid on the 1 centimeter square grid one face has been drawn for you. So if you look at this, this is 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. This is 4 by 6, which is your side part, this part. This part is drawn. So if we open this net, we can say that we have the 4 by 3 side over here, and again the 4 by 3 side over here. Then we have 6 by 3 over here. This is the top, and then again the side, 6 by 4, and then again 6 by 3. So this is a complete net of this cuboid. Then it says simplify 6a plus 4b minus a minus 5b. So once again, collect the like terms. 6a and minus a are like terms, and 4b minus 5b are like terms. So 6a minus a is 5a. 4b minus 5b is minus b. Factorize 6x plus 15y. So in this case, what we do is we look for the highest common factor. Is there a highest common factor between 6x and 15y? Yes, it's 3. Because 6 and 15 both come in the 3 times table. So we take 3 common outside. 6x divided by 3 is 2x. So 2x is inside. 15y divided by 3 is 5y. So 5y is inside the bracket. So as you can see, we took the highest common factor outside the bracket and everything else is inside the bracket. Simple factorization because also it's just 1 mark. Then over here, same thing. Is there a highest common factor? Yes, that's x and y. So we take x and y common. X squared y divided by xy is x. And then 5xy divided by xy is 5. The reason why I did not take x squared common is because we don't have an x squared with 5xy. It's just x. We have to take the highest common factor. So if it was x squared with both the terms, then we could have taken x squared common. But since it's just x and x squared, then x is the highest common factor, not x squared. So we take xy common and the remaining terms are inside the bracket. By writing each number in the calculation correct to one significant figure, find an estimate for the value of this. So 42.8 correct to one significant figure is 40. 17.4 is 20. 1.97 is 2. And 5.79 is 6. 40 plus 20 is 60. 2 times 6 is 12. 60 divided by 12 is 5. That's your answer. When you talk about significant figures over here, especially in this type of question, try to round it to a whole number. And for that whole number, you need to remember that leading zeros are not significant. So if we write 400, this is just one significant figure. This is your significant figure. These leading zeros, they're not significant. That's why 42.8 correct to one significant figure is 40. And for decimals like 1.97, the closest whole number is 2. And since just one digit, that's already one significant figure. So that's why the denominators were 2 and 6. But for the numerators, remember, leading zeros are not significant. However, if it was 401, then this is 3 significant figures. Why? Because now the 0 is in the middle. It's not leading the number. So if the 0 is in the middle, it is significant. If it's just a line of zeros at the end of the number, they are not significant figures. Then says the diagram shows 2 straight lines intersecting 2 parallel lines. Find the value of x, give a geometrical reason for your answer. This is x. So x is the same as 50. Why? Because these two are alternate angles. And alternate angles are equal in parallel lines. For you to remember alternate angles, you can remember the letter Z. Because if you highlight the lines like this, they're basically making a letter Z. So these two in the middle of these two lines are your alternate angles and they're always equal. Then it says find the value of y. So for y is equal to 110. Why? Because corresponding angles. Corresponding angles are equal. So for this, you need to know about your angles in parallel lines. We have corresponding angles, we have alternate angles, vertically opposite angles, co-interior angles. All of these angles are a part of parallel lines. And for you to remember corresponding angles, you can use the letter F. Because if you highlight this, this makes an F. So F for corresponding, Z for alternate. Then find the value of Z. So for value of Z, we can see that this is a straight line. So if you know angles on a straight line add up to 180. So these two angles added up equal to 180. So for this angle, let's call this A. A equals to 180 minus 110, which is 70. This is 70. Now, if you connect these lines, we can see that we have a triangle. And sum of angles in a triangle is also equal to 180. So basically 70 plus 50 plus Z equals to 180, which means Z would be 180 minus 70 minus 50, which equals to 60 degrees. So angle properties are very important, as you know, and you need to know by heart because you can't use the calculator for this either. Then it says a box contains 10 counters. The counters are either red or green. The ratio of red counters is to green counters 1:4. Shireen picks a counter at random, notes its color, and puts it back in the box. She then picks a second counter at random. Complete the tree diagram. So the ratio of counters is 1:4. And there are 10 counters in total. So let's find the number of red counters and green counters first. So for red, it's going to be 1/5 times 10. Why 1/5? Because when you're trying to create a fraction from a ratio, numerator is the number assigned to that object. So red is 1 and denominator is the sum of the numbers in the ratio. So 1 plus 4 is 5. So 1/5 of 10 is 2. So which means we have 2 red counters. And for green, it's obviously going to be 8 because there are 10 counters in total. And 10 minus 2 is 8. So now for the probability tree diagram, the probability of getting the red is 2 out of 10. And for green, it's 8 out of 10. Since she's putting back the counter in the box after she's taken out the first counter, that means the total number of counters are remaining constant. So the probability of red for second counter would also be 2 out of 10. And then again 8 out of 10, 2 out of 10, and 8 out of 10 again. So these are your probabilities for the probability tree diagram. In the case she was not putting back the counters, then for the second counter, your total number of counters would change. And so would your number of counters for the counter she's already taken. So for example, if she was taking the red counter, then it would be 1 out of 9, given that she's not putting it back. For green, it would be 8 out of 9. Number of green counters would remain same because she didn't take those out, but the total number of counters are changing because there's 1 less counter now. Over here, it would be 2 out of 9, and it would be 7 out of 9. So this is for the case when she doesn't put back the counter. And this is for the case when she's putting the counter back. So as you can see through this question, I explained very two different things to you, which most kids confuse almost all the time. Then it says find the probability that both counters are green. So for both counters being green, we do 8 out of 10 times 8 out of 10, which is 64 out of 100. That is the probability. If you want to simplify it, you can simplify it and it becomes 16 out of 25. 64 out of 100 would also work, but you can even simplify it if you want to. 64 out of 100. Then it says the scatter diagram shows the price of petrol per liter and the number of liters sold at a petrol station on each of 10 days. These are the results for 2 more days. Plot this information on the scatter diagram and then what type of correlation is shown in the scatter diagram. So let's plot these. We have 1.68 and 90, 1.47 and 380. That's over here. And 1.47 and 380. That is the other point. So now for the correlation, we can see that it's negative correlation because as the price of petrol is increasing, your number of liters sold are decreasing. When one thing is increasing and the other thing is decreasing, that means it's negative correlation. When both things are increasing, it's positive correlation. And if all of the points are scattered around, like there's no link, that means there's zero correlation. So negative correlation. Then it says on the scatter diagram, draw a line of best fit. And then one day the price of petrol was 1.55 per liter. We need to find the number of liters sold for that using the line of best fit. So for 1.55, we have to find the number of liters sold. First, let's draw the line of best fit. So for the line of best fit, you have to make sure that equal number of points are coming above and below the line. For the line of best fit, I'm going to pick this line. We have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Yeah, it's pretty even. And for 1.55, I'm getting 270 liters. This is the number of liters I'm getting using the line of best fit. Then it says points A, B, and C lie on the circle center O. Work out angle BCA. So for angle BCA, this is the angle that we're trying to find. So for this, you need to know your circle theorems because if you notice, the triangle is coming out of the diameter and the third vertex is touching your circumference, which means this is 90 degrees. Angles in a semicircle are 90 degrees. This is one of the circle theorems. So this is 90. Angle BCA is going to be 180 minus 90 minus 39. Sum of angles for a triangle is 180 degrees. So using that, we just subtract 90 and 39 from it. And that gives us angle C, which is 51 degrees. That is your answer. Then it says A equals to 2 cubed times 3 and B equals to 3 squared times 5. Find the highest common factor of A and B. So for the highest common factor, let me break these down. A is 2 times 2 times 2 times 3. B is 3 times 3 times 5. So for the highest common factor, we need to see which numbers are common. We know 1, 3 is common between A and B, and that's it. No other term is common. 2 isn't present in B and 5 isn't present in A. So it's 3. That is your highest common factor. Now for the lowest common multiple, the rule is different. We take all the numbers, but we take the highest power for each number. So the numbers we have are 2, 3, and 5. For 2, the highest power is cube. So 2 cube. Then for 3, the highest power is square. So 3 square. And 5 only exists once. So this is your LCM. For HCF, we picked the highest common number. So the highest common number was 3. And we only picked 3 once because A doesn't have 2 3s. It only has 1 3. So you pick 1 3. And for LCM, We take all the numbers, but for each number we pick the highest power. 2 has the highest power of 3, 3 has the highest power of 2, and 5 has the highest power of 1. So that's 8 times 9 times 5, which equals 360. That is your LCM. So this is how you can differentiate between LCM and HCF. Another thing you can do for LCM is that you can make the division table. 2 cube is 8, so 8 times 3 is 24. Write 24 over here. And then 3 square is 9, 9 times 5 is 45. So write 45 over here. You start dividing 24 and 45 until you reach 1. So 24 and 45 both come in the 3 times table. 24 divided by 3 is 8, 45 divided by 3 is 15. 8 and 15 don't come in the same times table. So since they don't come in the same times table, 8 divided by 8 is 1. And then 15 divided by 15 is 1. So 3 times 8 times 15. So same thing, 3 times 8 times 15, and that also equals to 360. So whichever way is easy for you to remember, just use that and you'll get the right answer. Then it says, on the grid, draw the image of triangle T after rotation of 90 degrees clockwise, center 0, 0. This is our center of rotation, 90 degrees clockwise, which means it's going to go in this direction. So that means it's going to look like this. So this point will come over here. This will be over here, and this will be over here. Now, how did I figure out where these points are going to be? When we're rotating 90 degrees, whether it's clockwise or anti-clockwise, what we do is we swap the horizontal and vertical distance that we have for each point with respect to the center. So this point has one horizontal and one vertical. So if we swap them, it's the same for this. However, if we take this point over here, this is 1 horizontally, 3 vertically. Now it's 1 vertically and 3 horizontally. For this one, that's 1 vertically, 4 horizontally. Now it's 1 horizontally and 4 vertically. So as you can see, you can swap the horizontal and vertical distance of each point from the center, and then that gives you the image of the shape after a rotation of 90 degrees. Then describe fully the single transformation that maps triangle T onto triangle A. For triangle T onto triangle A, as you can see, the size of the shape isn't changing, so it's not an enlargement. Since the direction of the shape is not changing, it's not a rotation or reflection. So what's left is translation. In translation, the size of the shape does not change. What changes is that we move the shape either up or down or left or right. Over here, we moved it down and then towards the left. So that means we need to figure out the translation vector. So first, let's write it's a translation by vector. Now for the translation vector, you can pick corresponding points on both the shapes and see how it's changing. This point has the coordinates of 1, 1. This point has the coordinates of -5 and -3. So from 1, we became -5, which means we move 6 units to the left. So first number in the translation vector that we write at the top, that's the x value. So it's going to be -6 because we moved 6 units to the left. Now from 1, we came to -3, which means we went down 4 units. So 4 units down. So the translation vector is by the vector -6, -4, because we're moving 6 units to the left and 4 units down. Simple as that. Describe fully the single transformation that maps triangle T onto triangle B. So triangle T onto B, we can clearly see that the size has changed. It's bigger, which means it's an enlargement. So we have one thing down, it's an enlargement. Next thing we need to find is what is the scale factor of the enlargement. For the scale factor, what we can do is we can compare corresponding sides and see how it has changed. This is 2 units, this is 1, 2, 3, 4. So obviously 2 became a 4, which means the scale factor is 2. Now we need to figure out the center of enlargement. For the center of enlargement, what we do is we join corresponding points on both the shapes and see where those lines intersect. So all of these lines, will pass through the same point. And I think that point is coming out to be 0, -2. That is your center of enlargement. So we'll just write this down over here. Enlargement by scale factor of 2 about the center 0, -2. So as you can see, we have 3 marks. So 1 mark for each point. 1 mark for enlargement, 2nd mark for the scale factor, 3rd mark for the center. For the other one, we had 1 mark for the translation and the 2nd mark for the translation vector. Each step represents a mark. So you need to be sure that you're giving all of the answers according to the given marks. Then work out 1 whole number 1 over 3 plus 1 whole number 3 over 4. We have 2 mixed numbers being added. So first, let's convert the mixed numbers into improper fractions. For that, you multiply the denominator with the whole number and then add the result to the numerator, which means 3 times 1, which is 3, plus 1, 4. So 4 over 3. In this entire process, the denominator remains the same. What changes is the numerator. So now again the same thing, 4 times 1, 4, plus 3, 7. So 7 over 4. Next thing you need to see now is whether the denominators are equal or not. Since the denominators are different, so what we need to do is make the denominator same. So to make the denominator same, what you can do is you can multiply the first fraction by 4, which is this denominator, and the second fraction by 3, which is the other denominator. Make sure that you multiply both the numerator and denominator by these numbers, not just the denominator. The entire fraction gets multiplied. So now we have 16 over 12 plus 21 over 12. 16 plus 21 is going to be 37. 37 over 12. Now we have to change this into a mixed number because that's what the question says. So for that, you divide 37 by 12. We know 12 times 3 is 36. So 3 whole number 1 over 12. This is always your numerator. This is your whole number. Denominator is the same. So that's your answer. Then write 32,500 in standard form. So this is ordinary number right now. Standard form is that form where we multiply a number by 10 to the power of something. So like I said previously, every whole number has a decimal at its end. So we move this decimal 1, 2, 3, 4 places. Why 4 places? Because in standard form, the first digit before the decimal has to be a non-zero digit. So it's going to be 3.25 times 10 to the power of 4. That is your standard form. Then now we have to write the standard form into ordinary number. So for that, we need to get rid of the 10 to the power of this. So if it's 5.6 times 10 to the power of negative 3, that means we're going to move the decimal 3 places to the left now. If the power is negative, that means the decimal moves to the left. If the power is positive, the decimal moves to the right. So it's going to be 1, 2, 3, which means it's going to be 0.0056. That is your number in ordinary form. Then simultaneous equations. So to solve simultaneous equations, you can either use the elimination method or the substitution method. Whichever is easier for you to understand, just pick that. In this case, I would advise going for elimination because it's going to be much simpler. With substitution, you'll have a fraction, and then going into fractions for paper 1 is not even advised because you don't have a calculator and you have a very high chance of making an error. So this is your chance to make your calculation easier, not more difficult. So let's use elimination method. First thing you need to do is pick the variable you want to eliminate. I'm going to pick x. You can also pick y, there's no restriction. To eliminate x, what we need to do is we need to check whether the coefficients of x are the same or not. If you're someone who doesn't know what coefficients are the numbers that are written next to the variable. So the coefficient of 2x is 2. Coefficient of 3x is 3. So as we can see, the coefficients are not equal. Hence, we need to make them equal. We can only make them equal if we multiply the first equation by 3 and the second equation by 2. This way, both the numbers will be same. And remember, you have to multiply the entire equation by this number, not just that specific term. So it's going to be 6x plus 15y equals to 15. And then 6x plus 8y equals to 22. Once you've done that, now we have to see, in order to get rid of x, do we add the equations or do we subtract them? Clearly, we can see that both the x are positive, which means if we add them, it will not get eliminated. Hence, we subtract it. So 6x minus 6x is 0. 15y minus 8y is going to be 7y. And 15 minus 22 is going to be negative 7. So we have 7y equals to negative 7. Now y equals to negative 7 divided by 7, and that's negative 1. To find the x value, put this back into either of the equations. I can pick the first one. 2x plus 5y equals to 5. 2x plus 5 times negative 1 equals to 5. That's 2x minus 5 equals to 5. 2x equals to 10. X equals to 10 divided by 2, and that's 5. These are your values of x and y. And with that, we're done with paper 1, variant 1. For IGCSE Cambridge Maths, paper code 0580, I'm going to post the videos for the other variants for all papers in the coming days. Stay tuned. And if you have any questions or confusions, please ask in the comments. And if you understood everything, please like and subscribe and share this video with your friends.